All right, y'all, this is going to be note card 34. It is called the mean value theorem. So what the mean value theorem says, again, it's a theorem, so there's a couple conditions that have to be met before we know that has to be true. But it says if f is continuous on the interval, on the closed interval a to b, and differentiable on the open interval a to b, there exists a number c in that open interval such that f prime of c equals f of b minus f of a all over b minus a. Verbally, that says where the instantaneous rate of change equals the average rate of change, and graphically it says where the tangent line is parallel to the secant line. So let me do a picture to help you understand this theorem. So here we go. So say we have some function So the two conditions for the MVT is that f needs to be continuous on the closed interval a to b, and it has to be differentiable on the open interval a to b. Okay, so I drew a graph right here. Let's say that this point down here is A and this point down here is B. All right. If I were to draw in a secant line between these 2 points, and let's draw in a secant line between those 2 points. The slope of this secant line, and the slope of the secant line is what we call the average rate of change. All right, so here the slope of the secant line how do we find that? Well, it's a slope, so it's a rise over a run. That's the y value for a, which we would call f of a, and this is the y value for b, so we would call it f of b. So the rise is the difference in these two. So the slope of the secant line is what's called the average rate of change between a and b. And we would kind of find that by f of b minus f of a, that's the change in y, over the change in x, which would just be b minus a. Now what the mean value theorem says, as long as this function is continuous and differentiable, then there's got to be a point somewhere between a and b. Okay, let's say that point, or there's got to be a point between a and b where the slope of this secant line equals the, maybe it's about right there. If I drew in a tangent line right there, there's got to be at least one point. There can be more than one, but there's got to be at least one point where that red line is parallel to the green line. So here, this is the tangent line at a point. Okay, and that's known as the instantaneous rate of change. So there's got to be at least one c value. Okay, and there's got to be at least one c value that's in between a and b where the slope of this red line is the same as the slope of this green line to make those two parallel to each other. Well, what's the slope of this tangent line? That would be the derivative at the point C. The derivative at the point C. So that's the slope of the tangent line, which is known as the instantaneous rate of change. Now these conditions have to be met. Okay, these conditions have to be met. Let me show you why they have to be met. Let me do another example. Okay, let's say it met the first condition, but it did not meet the second condition. Okay, so what I'm going to do here all right, let's say that this is the A value and this is the B value. If I draw in a secant line between A and B, okay, if I draw in that secant line, the slope there would be 0. Okay? Because they both have the same y value. Both of those points have the same y value. Okay? There's nowhere on this graph where the slope of the tangent line would be 0. At this point, that's a cusp, so it's not differentiable there. There's no point within A to B that also has a slope of 0. So it violates the second condition. It's not differentiable between A and B. Okay? It's continuous. It met the first condition. I can draw that without picking up my pencil, but it's not differentiable. So the mean value theorem does not apply. So here the mean value theorem doesn't apply because f is not differentiable. Okay, at this C. It's not differentiable there. There's a cusp, which means that the derivative at C coming in from the left does not equal the derivative at C coming in from the right. So let's look at several examples here. So let's look at number 1. It says, let f be the function given by this thing. Find the number c, okay? So find this number c that's in between 1 and 3 that satisfies the conclusion of the mean value theorem. Okay? I'm just going to do this on another piece of paper. So the function is x cubed minus 7x plus 6. If I wanted to find the average rate of change on the interval 1 to 3, then what would I do? I would just take the slope of the secant line. So I would do f of 3 minus f of 1 over 3 minus 1. Okay. But before we actually do that, this is a polynomial. If we're going to use the mean value theorem, then we have to say the conditions are met. Okay, so we're going to say that polynomial functions are continuous and differentiable. Because if I take the derivative of that, it's going to be continuous everywhere too, which means that the original has to be differentiable over all reals. Okay, so I stated the conditions that we're going to use. Now let's actually figure out the average rate of change. So how do I figure out f of 3? Everywhere I see an x, I'm going to plug in 3. So 3 cubed minus 7 times 3 plus 6. And 3 cubed is 27. 7 times 3 is 21. Okay. 27 minus 21 is 6, plus that other 6. So that's going to give me 12. All right. Let's figure out what f of 1 is. So I'm going to be 1 cubed minus 7 times 1 plus 6. 1 cubed is 1. Negative 7 times 1 is negative 7 plus 6. 1 minus 7 is negative 6. So that's going to be 0. So once I know these two values, I can plug it in here. So f of 3 was 12 minus f of 1 was 0 over 3 minus 1. So that'd be 12 over 2. So that's 6. So 6 is the slope of the secant line. Now, we want to figure out where the slope of the tangent line also equals 6. So let's figure out what f prime of x is. Well, here's what f of x was. So the derivative would be 3x squared minus 7. We want to figure out what number can I plug in for x to make the slope of the tangent line come out to 6. So, just doing some algebra here, add 7 to both sides. Gets those to go away, so now I have 3x squared equals 6 plus 7 is 13. Divide both sides by 3. So now I have x squared equals 13 thirds. All right. We want to solve for x, so we're going to square root both sides, and we're going to put a plus or minus. So x equals plus or minus the square root of 13 thirds. Okay. However, the c value, the calculus tells me there's 2 answers, but remember what the interval was, 1 to 3. One of these numbers is not inside 1 to 3. Okay, so if you think about these individually, x could equal the square root of 13 over 3 or negative square root of 13 over 3. Okay, so what is 13 over 3? It's a number a little bit bigger than 4. It's 4 1/3. So if I take the square root of 4 1/3, it's going to be 2 point something. Okay, 2 is inside here. But if there's a negative in front, this means negative 2. This cannot be the answer because that's not in between 1 and 3. So my only answer that works is this. Okay. So what I'm saying here is that f prime at the square root of 13 over 3 equals 6. Okay. Which equals so this is the slope of tangent line, and here's where it happens. So I just want to show you graphically what we have here. So let's put in the original function. Okay, let's put in x cubed minus 7x plus 6, but I'm going to change my window. I only care about this between 1 and 3. Okay. And let's just do a zoom fit after that. Okay. That's what the function looks like here. Okay. So if you think about the secant line between these 2 points, all right, it reaches a high point at 12, a low point, or it starts at 0 up to 12, so rise is 12, and you're running 2. So 12 over 2 is 6. All right. Now I think where the slope of the tangent line is. Okay. So let's see if I don't know if it'll let me draw on a secant line. No, it's not going to let me draw on a secant line. But what I can do is, if I hit second, calculate, go to option 6, let's calculate the derivative at the point square root of 13 over 3. And hopefully you can see right there. Okay. If I drew on a tangent line right there, it would be parallel to the secant line on the endpoints. Okay. The slope of the tangent line there is 6. we know that the slope of the secant line is also 6. As you can see, this function is continuous and differentiable. Let's look at the next question. So number 2, it says let f be the function defined by this. What is the value of c for which the instantaneous rate of change, okay, so this is slope of the tangent line, is the same as the average rate of change over the interval 1 to 4. Alright, so f of x here is x plus ln of x. Let's first find the average rate of change over 1 to 4. So that would be f of 4 minus f of 1 over 4 minus 1. All right, now this is a calculator question. All right, so I'm going to go ahead and put this into y1, x plus natural log of x. If I wanted to graph it, I care about it from 1 to 4, and then I can do a zoom fit. So there we go. Now if I want to find the average rate of change, quick way to do it, go back to my home screen, make a fraction, and say, okay, I want to take y1 at 4, that's the y value at 4, minus the y value at 1, all over 4 minus 1, can do it in one step. Okay, so that's about 1.462. That's the slope of the secant line. Okay. I'm going to store this just as an answer so I can keep it in there, 1.462. I want to figure out where does the slope of the tangent line also equal 1.462? Well, what's the slope of the tangent line? Slope of tangent line means derivative. Okay. So f prime of x equals derivative of x is 1 plus derivative of natural log of x is 1 over x. So here's the equation for the slope of the tangent line. I want to figure out where does that equal 1.462. And I can use my calculator to help me out here. Okay. So here's what I'm going to do. I'm going to go back to these functions. I'm going to turn off the original function. And I'm going to put the derivative in there. So 1 plus 1 over x is the derivative. Now I want to put in that 1.462, which I stored as a, so I'm just going to hit a. For my window, I'm going to stay with 1 to 4 because that's the interval I care about. I'm going to do a zoom fit again when I get down to y min. So here's the derivative graph. Okay, and then here comes the line 1.462. I want to figure out where did they come together. So if I go second calculate, intersect, I'm going to get close to the intersection there. Enter, enter, enter. And there's the x value that makes it work, 2.164. So that only works when x equals 2.164, which is a number between 1 and 4. Okay. So if I take f prime of 2.164, it should come out to 1.462. Here's a way we can make sure. go back to your y equals, turn off the derivative, turn off that line, go back to the original function. Here comes the original function again. Let's go ahead and hit second calculate. Okay. We're going to calculate the derivative at 2.164. What do you notice here? It's 1.462. So if I drew in a tangent line right there, okay, imagine drawing in a tangent line right there, it would be parallel to the secant line that I would draw between the endpoints. Okay. Now we do have to say one more thing. Look at this curve. This curve is continuous, okay, because you can draw it without picking up your pencil. And it's also differentiable because there's no hard corners, there's no cusps, and there's no vertical tangents. Okay, so we would say MVT is conditions are satisfied, f of x is continuous and differentiable over the interval 1 to 4. So the answer that they want here is this. They want to know the x value. Okay, they're calling it a c value, but the c is an x value. All right, let's look at the last question. It says, let f be a function that is differentiable and also the second derivative is greater than 0. Okay. Using the chart below, find a positive number r having the property that there must exist a value of c between 0 and 1/2 and f double prime of c equals r. Okay. So here this second derivative equals r. Okay, that equals r. The second derivative equals r. Well, as long as, go back one, so just kind of, if you kind of think about what does the mean value theorem says, it says f prime of c equals f of b minus f of a all over b minus a. If you go forward a derivative, okay, what that means is that f double prime of c would equal f prime of b minus f prime of a all over b minus a as long as f, okay, as long as f prime, was continuous and differentiable. So how do we know that f prime is continuous and differentiable? Okay. Let's see. I guess we really don't unless it says twice differentiable. Okay. Let's assume it just says twice differentiable. Okay. So what does it tell me about this thing? Okay. It tells me that f double prime of c is r. That equals r. Equals. Well, they also give me an interval. They say between 0 and 1/2. So to figure out what r is, all I have to do is do f prime of 1/2 minus f prime of 0 all over 1/2 minus 0. So the reason I gave you information about f is to try to throw you off. Okay. So if I look at f prime at positive 0.5, it says here it's 3. So 3 minus f prime at 0 is 0 all over a half minus 0, so that would be 3 over a half. Okay. And 3 divided by a half is the same thing as saying 3 times 2, and that equals 6. So I just figured out that the value of r is 6. So let's see what this is saying. This is saying, how do I know that it tells me f is differentiable, so that automatically implies that f prime is continuous. Okay, so that does imply that. But how do I know that f prime is differentiable? It does tell me here that the second derivative is positive. So what does that mean about f prime? That means it's strictly increasing. Okay. It does tell me that it's strictly increasing. So if I were to plot all these points, it's never going to drop down below its other values, which means that there's not going to be any hard corners. It's not going to change directions. So that gives me faith that it's differentiable. Okay. So there's that. All right, so that's it for this note card. Let's look at a couple problems from the homework. So in the beginning here, it says use the graph of f to estimate the numbers in 0 to 8 that satisfy the conclusion of the mean value theorem. So here's an x value of 0, there's the x value of 8. Go ahead and fill in these points, and then what you can do, using a straight edge or a ruler, go ahead and draw in the secant line between those points. And now kind of just move the ruler up until you think you get to the point where there would be a tangent line. So to me, I'm just trying to draw parallel lines to that. So to me it looks like there's one about right there. Okay, that blue line is parallel to that red line, and what value did that happen at? To me it looks like it happens at 5. Okay. And there might be another one. So again, if you go from the secant line, you kind of move it along, move it up and down to keep it parallel to it. To me, it looks like about right here as well. Maybe about right there. So if I estimate where that happens, okay, maybe about 1.6. Okay. So that's how you do that. This green line and blue line and red line are all parallel to each other. Down here at the bottom part, okay, and you do the same thing for number 2 as you just did in number 1. All right. In exercises 3 through 10, determine whether f satisfies the hypotheses or the conditions of the mean value theorem. So what does that mean? It needs to be continuous and differentiable. Okay. So before you start working things out, make sure these functions are continuous and differentiable. Okay. This is a polynomial. It's continuous and differentiable everywhere. Both of these are trig functions, and each one of these are continuous and differentiable everywhere. Therefore, even if you subtract it, it's going to be continuous and differentiable everywhere. Okay. This one has a vertical asymptote, but it has a vertical asymptote at -1. -1's not in the interval. So this one's actually going to be continuous and differentiable over this interval. Not over all real numbers, but over that interval it will be. Okay. Here, okay, this is continuous and differentiable over that interval. Take a look at that graph, take a look at this graph. Okay, look at some of these other graphs. And if you're not sure what they look like, Maybe use your calculator or maybe make a table of values to help you out. Some of these are not differentiable. 11 and 12 should just be reviewed for you. Okay, and that's the only assignment tonight for packet 34. So again, mean value theorem, we're figuring out, as long as the function's continuous and differentiable, we're figuring out at what x values the slope of the secant line equals the slope of the tangent line, or where the a rock equals the I rock.